Okay, so hello everyone. So welcome to the introduction to the Docker container. So container are actually completely isolated environment, and they have their own processes, network interfaces, their own mount point, but they share their same operating system kernel. So before going to why we need a container environment, first let's have a look what is the gap with virtual machine that container is going to fulfill. So let's have a look on this architecture. So in virtualized environment, what we have is we have a base operating system that may be Linux, Windows or Mac, and on the top of that we installs any hypervisor. So it may be VMware, EXXI or workstation or VirtualBox or other hypervisors, and on the top of hypervisor we install multiple operating systems. So it may be Windows or Linux. So even in Linux it may be Ubuntu or CentOS or other distributions. So we have a separate operating system, and each operating system has their own resources allocated. They have their own kernel, and on the top of that we install any applications. And obviously applications has some libraries, some dependencies. Okay. uh, Next thing is, so if we have any application that may be working on one of the uh, uh, s- operating system, but if same application needs to be moved to the another uh, operating system, so in that case we may have a dependencies issue there. And if even if we solve one dependency, there is chance that we may have another dependencies, so that this containerized application or Docker container will fulfill. So in case of container, we have a single operating system. On the top of that we install uh, some Docker or Podman. So what Docker is, the main purpose of the Docker is to package and containerize the application and ship them to run anywhere anytime. So if I have application that is containerized with Docker, so suppose I have one application, and if we move this application to another server, so even on new server there will be no dependency, because it is completely the isolated environment. So in case of this uh, uh, container, we have single operating system. We have a container engine like Docker. So why Docker is required? So setting of these containers uh, environment is hard, as they are a very low level, and this is the place where this Docker provide high level tool with different powerful functionalities, making it really easy for end user like us to manage these containers. Further, if you see the difference between two diagram, I have this one for a virtual environment and this for containerized environment. So if you see here, the utilization, resource utilization, that may be RAM, CPU or disk or other things, is high, because we have to install the operating system separately. But this is not the case with containerized application. So we have single operating system, but with the help of Docker tool, we can manage multiple containers. Similarly, since operating system are very large in size, maybe in GBs, so it uses high disk usage. But this Docker application running inside the Docker container will only use the dependencies and most of the time these dependencies and libraries are in their size are in MBs, so it will use less disk also. So operating system takes time to boot, maybe few minutes, but Docker container can be up in within few seconds. Beside that, in operating system we have a separate operating system in virtualized environment, but in this case, in the case of container, we will have a shared operating system kernel for all the container running here. Beside that, in virtual environment, uh, the resources are allocated at initial stage. So if you want to uh, provide 4 GB RAM, 2 core CPU, or 100 GB disk, so this will be allocated at the initial state. But in case of this containerized application, it will there will not be a requirement to allocate the resources initially. It will only use the resources once it is running, or how much this application requires. So it will only utilize the resources from this operating system. Okay, so our next thing is to run this container. We first need the image to run the application. So we need the image of the application to create the container of that application. So you can consider image as a seed of a fruit or anything, and container as a tree. So container is actually a running state, and image is uh, a file used to execute the code in Docker container. Here if you, okay, so uh, where from where we can get these images. So there are many hosted repositories, service provider. So they are Docker Hub, Docker Hub, or Quay.io, or registry.redhat.com. So there are large number of hosted repository service provider that contains the base image of hundreds and thousands of applications. So let's take the example of Docker Hub. So let's log into the docker.io. So if you can sign up here, and here you can see a large number of hundreds and thousands of images. So if I want to check for nginx, so nginx images, so we have these images. So if you search for another MongoDB, so we have MongoDB images. So there are large number of images present on the Docker Hub. Similarly, there are Quay.io equivalent to this Docker Hub. So actually, Docker Hub uh, is a hosted repository provided by Docker for finding and sharing this container images that we required. So nginx or httpd base image or tomcat base images. Okay, so these are base images. Now suppose I want to create my own images. So how can we do that with my own application? So suppose I have a Java developer, and they have developed one Java web app file, and this is packaged file, that is java web app.war file. Now if I need to create this custom images with this uh, web app java web app file, so how I can do that is I can download the base image from the Docker Hub or any mm, uh, hosted repository service provider. So I can download Tomcat base image, and I will then add this uh, web app to create a custom Java web app, right? So we can add this our developed web app with the base web app to create our custom uh, images, and with the help of that custom images we can use Docker to create a container for this custom Java web app. Similarly, in case of Python, if there are any Python application developed, we can create our uh, custom container, sorry, custom image, and with that image we can create a container. Similarly, if I have one PHP application, I can containerize, I can create a custom image with the help of that PHP uh, file, and I can create then container with that custom image. Now, so actually, if in case of container, it can only be locally accessible. So suppose I have one machine, suppose this is CentOS machine, and I have installed Docker, and on the top of that there are three container running. So if I need to access the container from outside, I cannot directly access that container. So there needs to be some port mapping. So suppose I have this CentOS machine and whose IP is 192.168.18.205. So I need to port map with some unused port. So suppose I have 4567 and this Java application is suppose running on port 80. So I have to map the 4567 port to 80 port, and then only from outside world I can access this application. But suppose I only need to access the application from the same host or locally, then I don't need to uh, configure the port forwarding. Okay, so this is all about the introduction on the Docker container. uh, in the next video I will show you how we can download the base image from Docker Hub, how we can create image, how we can create a custom image, how can we create uh, containers, so multiple containers on the same operating system. So I will show you all these things in the next video. Thanks for watching.